Hi, today we're going to be talking about the IV characteristic of an inductor. Like we saw with the resistance at that time, the IV characteristic of a resistance is basically described by the Ohm's law. And if we plot the voltage against the current of a resistor, we get a straight line. The IV characteristic of an capacitor is described by two equations that involve an integral on one side or a derivative if we take the other one. And now we're going to see the one that describes the inductor. So for the inductor, the voltage in the inductor is equal to the inductance times the derivative of the current. And likewise, the current is described by the integral of the voltage. So if we remember from our capacitor videos, we remember that the capacitor stores voltage. In this case, the inductor stores current. So it's useful to compare them so that we see what they're doing. So if we have here our inductor, and if we put here our capacitor equations, the voltage in the capacitor is the integral of the current, and the current in the capacitor is likewise the derivative of the current of the voltage. So from here we can clearly see that what the capacitor does to the voltage, the inductor does to the current, and what the capacitor does to the current, the inductor does to the voltage. So they are basically the same thing, but in opposite ways. Which this will be useful when we look at things like circuits with AC circuits or frequency response. We will basically get the same response as the capacitor, but the other way around. In the following videos, we will be talking about the response of the electric circuits that have got inductors in them. Thanks for watching.